Alright, hello everyone, my name is Timothy Lee Grant. Today we are continuing with the Neetcode Journey, so let's get started where we were stumbling yesterday. So let's see if we're able to find answers to those problems that I was having difficulty with yesterday. So we were looking at here in the stack, get temperature was one. Okay, so you are given an array of integers temps where temperatures of I represents the daily temperatures on the ith day. Return, okay, so this is what we need to return. Return an array results where result of I is the number of days after the ith day before a warmer temperature appears on a future day. If there's no day in the future where a warmer day will appear, then we have that as a 0. Okay, so from the video that I watched last night before I went to sleep, I remember that we're using a stack to do this, and the idea is, let's see. So I want to initialize a result, which is going to be this, and I want to have it initialized to all zeros, and then I want to look towards each day and see if it continues the decreasing trend. If it continues the decreasing trend, I want to pop from this. No, I want to add that value to the stack. If it increases a little bit, then I want to, in that case, pop the last element, the lower element, save that into here, and then check the other ones in the stack. Something like that. Okay, so let's see. I will have stack is equal to an empty list, and I will have result is equal to what is the notation? Is it 0 multiplied by length of temperatures? This might actually be wrong. I'll probably need to look into that. But I want to initialize an array which has this many elements, all of which are initialized to 0. Do I need to do like four in range length like that? Or can I just do, anyways, I'm gonna see if this works and just add that to my toolbox if it does. Okay, so we initialize this, and now I want to go through my temperatures. So I will move this down a little bit. There we go. I will do for element in temperatures. So I'm going to be going from here to here to here to here to here to here to there. And now a stack needs to be utilized for this. What are the conditions in which I need to possibly update my results? That would be if there is a higher day that was found, right? So if stack and stack at the last element is less than element, maybe this should be a while loop, I don't know yet. So I look at my stack, okay, so I have a thing here, and I need to see if the element is the current element that I'm looking at is bigger than the previous one. And that holds the previous one. So if it is, then I want to pop from the stack, right? And update my result. Because in that case, we found a day that was bigger. So stack.pop, and now I need to find, this is going to be the, what would that be? This is going to pop, well, I know that I need the index and the, okay, fine. So I know I need enumerate temperatures, and enumerate is going to take the index and the element. Previous val, previous index, okay, is equal to what gets popped here. And now I actually need to index this. So the last element's 0th index. And this would need to be a while loop, because I need to keep doing this while this new element value, right, breaks the pattern of being bigger than the previous trajectory downwards. So I just popped from the stack. Now I need to update my result. How am I going to do that? I am going to say result of the previous value, or of the previous index. And why is this the previous index? Because I found, let's say that I am right here, okay? I just found this one, and now I need to update this value to say how many days apart there is, right? And so I need to update this one's index right there. And I have 35 here. But this 40, it's going to look back at 35 And it's not going to put that on the stack, right? Or maybe 35 gets taken off the stack because I have to go here. I don't know. So this will get updated. What do we want to do? We have the index of the 2. So I will do my index minus the previous index. Okay. So that would update this one here. And then I'm going to look to the next one. So now stack contains just these elements. Wait, no, it would just contain this element. That's okay. And this is not true because I'm at 36, not 38. So then I go and I move to 35. So then I would need to update this one. So it would need to put this element on the stack. Outside of this while loop, I will stack.append. And I want to append a list where the value is the first index, element, and index, okay? All right, let me kind of walk through this and see if I can figure things out. So I'm gonna have my stack here. I'm gonna have result is equal to, and this one is gonna be like this. Okay, let's just do this. Actually, I might just keep this example. I kind of like that better. 0, 0, 0, 0. Okay, and stack is empty. So now I come here and while stack, so no stack yet, then I come here and I add the element, which is 5. And this right here is just temperatures, yeah. I was looking at it in temp, I was thinking temporary, and I was like, wait, that doesn't make sense. And now I get it. Okay, cool. So we add a list, which is 5 and index 0. Then I come back up here, I get this while loop again. Now we do have a stack, and I check if the last element, which is this one, 0th index, which is the 5 right there, okay, is less than the element, which is here. So actually I think this needs to be greater than, right? Because I just want to the stack is going to be I want, as it's decreasing, I just want to append things. So the stack at negative index. This is the previous value. If the value that I'm looking at is smaller than that, no, it is like this. Okay, so the previous one is 5, yeah, okay. And now I'm looking at 3, so element is... Why am I... This is ridiculous. I feel like in my head I have two different scenarios. When I think about it theoretically, so I'm thinking about the stack, I'm getting to one answer. When I do the loop through and actually do a physical example, I'm coming out with a different thing. So the stack represents the previous value. And I only want to update when the previous value is found to be bigger, right? When the previous value, if I'm on 36, and then there's a 30, that's when I want to trigger. Yeah. That gives me this. If I'm on 36 and I want to trigger on here and 30 is smaller, this is going to be in the stack. So I want like that. I want the element. This is element right here, 36, and I'm looking at the stack, which is previous, right there. So I want element to be bigger. Okay. So I'm looking at 3. Now it changed again. Now it changed. Why is it just... Feels like the fabric of reality is just changing in and out as I look at one thing to the other. Oh my gosh. This is just making a video of just going back and forth, just changing this sign. I feel so dumb sometimes. So if I'm here, this is element. Element 36. You are 36. Okay, you are 36 here, right there. Now what is the previous one? The previous one is 30. I want to trigger on this case, correct? Because we have a higher day, so I need to update this. So I need to trigger on this. I want this to be true. 36 is greater than 30. Yes. I want it to trigger. Oh, but I don't want it to trigger on 3. So I come here. This is 5, and that's 3, which means that it does trigger, but I don't want it to trigger. Wait, the fabric of reality just changed again. So this one is 30, okay, yeah. And this one is now, what is the previous one? It is 5. Okay. I'm just going to put this here again. 3. So this is, yeah, okay, there we go. Good. So then we add it. Okay, so let's, I mean, sorry if this is kind of a boring video, if I'm just like, I don't know, sorry if this video is really boring. Okay, so I need to add 3 and 1 here, okay? So then I come back up here, I say my stack is full, or exists. I look at the last element, it is 3, okay? And then I look at this element, which is 7, and 7 is bigger, so I do come into here. Okay, here we go. So now I pop from the stack, and I have this 3 and 1 as previous value and previous index. So result of previous index here, I'm updating it to be what? It is going to be index, which is currently at this one, so 0, 1, 2. So 2 minus previous index, which is 1, okay? Which simplifies down to 1, okay? Here. Then I come back up to my stack and I say, is 7 larger? So 7, or no, this one is 5, is less than 7, which is true. So we come in here and now we pop from here, okay? And now index is still at this 7, so 0, 1, 2. And we are going to update this. Just popped, we go to result, and we go to previous index, which is this one right here. So now I'm looking at the 0th index in my result. I update it to be our current index, which was 2 minus 0, okay? Which comes out to be 2. And then I come back up here and our stack is empty because we popped that one, right? So it's empty. Then I come down here and I append this with a list of value and index. Okay, so corresponds to this one. Then I come back up here, I look at my stack, I say, okay, there is something. It is 7, which is less than 9, okay? Then I come here, I pop this out. I then look at my previous index, which is 2. I do index, my current index, which is 0, 1, 2, 3. And then minus my previous index, which is 2. Okay, like this. And then I come here and I add to the stack here 9 and 3. And this is gone, right? Then I come back up here and I don't hit another one because we reach the end of this temp and then we're done. So, okay, I think return result. Let's see, we're gonna might get an error here. Might not like that. Okay. Okay. How to initialize a list of length temps, all being the value of 0. Okay, let's figure out how to do that. Oh, we have this 0. Okay, so it's a little bit different. I'm going to keep this length of temperatures, but we are going to put 0 in here and then multiply it by length of temperatures. Okay. Hey, okay. Come on. Yes! We got it. Every time I see this analyze complexity, because it's red, I just automatically think, like, just right when I see it, my brain associates, oh no, it failed. But then I look and see the acceptor, and I'm like, yeah. Okay. So, trying to make some observations on this question. It goes into the idea of, with my stack, I can put decreasing values in and pop the ones that I find break the rule. So I've been doing some problems in this stack section, and a lot of them have this very interesting way of dealing with those, like, minimum stacks and things like that. I guess I'm not quite catching the trick yet, but I'm noticing that there is some trick in there. Okay. So let's keep going. Okay. We got that one. Let's try this one. This one was one that was I failed yesterday. Okay, so all of this is nonsense. You are given a string S consisting of only uppercase English letters and an integer k. You can choose up to k characters of the string and replace them with any other uppercase English character, okay? After performing at most k replacements, return the length of the longest substring, which contains only one distinct character. Okay, so the way that I was going about it yesterday was completely wrong. This is, again, is one of those questions which I watched last night, I watched a video last night before I went to sleep, and so I'm going to try it again. All right. So let's have more coffee. I ended up sleeping like 3 hours last night. It was like Susie was, she works literally 7 days a week, and normally she'll get home at like 2:30 or 3:30 a.m. But I was waiting for her to get home, and it was like 3:30, almost 4, and I was like, oh, I have to get to sleep. She'll be there. She'll come home, and it'll be all right. Well, then I woke up, just like, a little bit groggy, still planning to go back to sleep. It was like 7. Wait, Susie's not here. What's going on? Like, she normally works very late, but it's kind of uncharacteristic for her just like not to show up. So I was pretty worried about that, and then couldn't go back to sleep at that point because I was worried about if she was doing okay. And then she sent me a message like at 11 something, and that's why I started this video at like whatever 11. I don't know, whenever it was, but like it was shortly after or shortly before I started this video because I was too stressed out about if she was doing okay because she, I guess, forgot her phone, and so she wasn't able to send me a message back. But then I got the message, and I'm like, okay, thank goodness she's all right. So yeah, didn't sleep very good last night. That's what I went to bed at 4, 5, 6, 7, 3 hours. So I'm tired. All right, but the good thing is she's doing okay. um, yeah, she's such a hard worker. Like, I can't even describe how hard of a worker she is. Literally 7 days a week. And she'll get to work at whatever, like 9 or 10, and then come home every single day at like 2:30 or 3. And it's like, oh my goodness. Yeah. So, anyways, let's even if we're a little bit droggy, let's try to get this problem. So, after performing at most k replacements, return the length of the longest substring, which contains only one distinct character. So we're allowed to change the characters. And this is a sliding window problem, okay? And what's going to happen is we need to find some way to keep track of the like most frequent letter. Okay, so what I think I'm gonna do is I'm gonna create a hash table. Now, yesterday, when we were looking at some of the solutions to a problem that we weren't able to get, there was a difference between hash table and hash map or something like that. I didn't spend too much time dissecting the difference. Maybe I should have. So I don't know if I'm using the wrong terminology. What I mean by hash table, hash set, something, I just made a dictionary. So my dict is equal to default dict. And what are we going to be storing in this? Char? Wait, and what's the Python string? No. String. Oh, okay. There we go. Okay, so string. Now, that's going to be the key. The value is going to be the frequency. So let me put a little note here. So key value. So key is going to be letter. Value is going to be, let me just take away the spaces so it's easier to read. Value is going to be frequency. Okay. So now I need to take my left and right pointer are initially going to be set at 0. This. They're both going to be pointing here, so I'm just going to get like left and right are here. And then actually it would be kind of like that. Both at the 0 let me kind of make this more clear. This is the 0th index, 1, kind of like that, right? So we're still at the this is the 0th index, but I haven't included this yet. I haven't processed this letter yet. So we're kind of here. So let's take that idea and let's put it into code. What does that translate to? Left is equal to 0. So I can say left equals right equals 0, kind of like that. And now what I should be able to do is try to move my right pointer over. So I kind of want to process this. So how do we process? So while right is less than length of s, okay, I want to first, I'll process it. Okay, and how do we process it? We do I want to update it right now, actually? Because I'm thinking, do I need to check if it is valid? So if do I check if it's valid first and then add it? Or do I add it and then... I would have to check if it's valid first, right? So if... Can I go like this? So this, I'm hoping, will give me back the number of the number of frequencies. So I want to get back the value. And I want to find the most frequent value. And I want to say that number minus my current window size, which is going to be minus right minus left okay. If that is greater than, so this is how many extra letters we have. If that's greater than my K, maybe I should say less than my K, then I want to, then this is valid, and I can continue to do something. I can update my result. So result equals max of result and the current length, which is that right minus left. Okay, so see if we have a larger window. And then otherwise, I want to move my left pointer. So while left is less than right, and the opposite is the case, I want to take away that value from my dictionary. So that is going to be indexed at S of left. So this is going to give me the letter, and I want to decrease the frequency by 1, and then I want to move my left plus equals 1, and I want to keep doing that until this is true. Okay, and then I want to add the frequency to the, so this is not process, just check. So then I want to add the frequency to, which is my right, so I want to do my dict indexed at S of R, okay, plus equals 1, and then R plus equals 1, so then move that over, and then return my result. Ooh, I don't know. We're probably going to get some errors on this. I don't think that's correct. I don't think you can do that. Yeah. Okay, let's take it to GPT. That's more of a syntax thing, so that's whatever. Can you tell me how to correctly iterate or correctly get the max of the values in my dictionary? Okay. And of course it's going to bounce all over the place. Max of dot values, so like that. Values. Okay. Should we run through the example? So it's 0, left, so right is here, okay? Then my result is, so this is saying that it is valid. Because we're at the 0, 0, right? So maybe I just want to actually just do this. Maybe I can do, copy this, come into here, do that, and then kind of delete these. That's what I'm thinking. So I come in here and left is less than or equal to, or it's equal to right. So we don't even hit this. We come in here, we take this left minus right, and now actually I want left minus right plus 1 because it means that the current is it the current one that I'm about to process though? Because this seems like a future R, right? That I haven't added yet. So maybe I do need to add it first. So maybe you go up. I have no idea what I'm doing. Maybe you go up there, okay? So now we're on the same page. We get the right, so that means we do process this. So process would mean kind of like that, okay? So now we have this in our dictionary. Then I check this, and so 0 and 0, they're left and right are both still at the 0th index, but we've now processed this. So this is not true because it's not equal to. So then I don't come here, I just find the result of this, which is left minus right plus 1 because we have one element in here. Okay, so this feels a little bit better. Then I do result plus equals 1, so that is going to be like this right here. So I haven't processed the y yet. Then I come back up here, I do this, which processes it. So I come here and process it, okay? And now I do this, so this is now true, because left is less than right, and I find the maximum of my values, which in this case is going to be 1, so that's 1, minus right, which is 1, and this is 0, so 1. So 1 minus 1 is 0. And so actually if this number is less than the number of times I'm allowed to change, but I think this should be plus 1 as well right there because I need to account for the one that I just added, right? So now we have right, which is 1, left, which is 0, so this is 2. 1 minus 2 is -1. Okay, what should the answer be here? I'm trying to have this expression here come out to be the number of values which I've used my swap ability within this window. So that means I take the largest frequency No, that means that I would take the length here. Oops. Copy that, and I paste this here. I take my length, and then I subtract the number of elements that were nice, that I didn't need to swap anything out. And now I say, so this is the number of elements that I needed to swap. If that is equal to k, we're still good and we don't need to move left over. But if it is greater than k, then we have a problem. Okay, yep, I think that makes sense. So now right is equal to 1, left is equal to 0, and then plus 1. So we have 2 here minus 1. So we have 1 right here, which means how many times we have used our swap capability, which is exactly what it would be, right? Because I swapped this once. So now it's an x. Is that greater than k? And k is 2. No, it's not. So we're okay. So we come here, we update this new result. So result is equal to right, which is 1, minus left, which is 0, plus 1. So we have 2 here, okay, which is exactly what we want because there's 2 elements here, okay? Then we move right over by 1. Like this. I come back in here, I add the frequency for this. So that's kind of like, whoops. That is kind of like processing this one, okay? So now I check we're still good here. Left minus right plus 1, so, or right minus left. So we have 0, 1, 2, 2 minus 0 plus 1, okay, is 3. We have 3 here. And now minus the maximum. The maximum is now 2. Okay, so 3 minus 2 is 1, which is exactly what we said, because that means that this x is now going to be changed to a y. So we only use the swap one time. And we say that is that greater than k, which k is 2. No, it's not, right? 1 is not greater than k, so we don't run this. We come in here, we update the result, we move this over by here. Then we come up here, we process it. Okay, and then this is fine. and we say that this is not going to hit because this is going to be equal, so we don't run this again. And then we update the result, which is going to be 0, 1, 2, 3, plus 1 is 4, so we store 4 here. We go to the next one, and now it's equal to the length, so we don't run this, and then we return the result, which is 4, which is exactly what we get there. Okay. Now, in the case where we need to update, I am going to decrease the frequency, yeah, and move L over until this becomes true. So this number is going to get bigger, which makes this get smaller, which this number is fixed, so that way every time this loop happens, this decreases and this condition goes towards a break condition. Okay. Should we press submit? How about we run first? Let's see if we get syntax error. Okay, so what's the problem with this one? Hold on. Int to string. Wait, hold up. We're keeping the key is going to be a letter. And then oh, maybe this actually has the, it's like this. Maybe this refers to the key. Okay, that's what it was. And then we can store, okay, yeah, that makes sense. Then we have the key is whatever we place into it. So we place in a string, and then we just want to say that we're storing the values, which are integers. Okay, let's see if it takes it. Come on, come on. Yeah, we got it. Okay, okay, okay. Here we go. Now let's keep going. Okay. Do we want to do this permutation of a string? I guess so. Okay. You are given two strings, S1 and S2. Return true if S2 contains a permutation of S1, or false otherwise. That means if a permutation of S1 exists as a substring of S2, then return true. Both strings only contain lowercase letters. So I have S1 and I have S2, and I need to find if S2 contains S1 in it in some permutation. So I need to check here, LEC. So there's no B and there's no A. So then I eventually come to this point where I see A, B, C, a permutation, and I say that that's true. Okay. This one is false. Even though we have an A, we have a B, and we have a C, there's no permutation of it that can allow us to get that. Okay. So obviously this one is, even though I didn't click on the topic, I know that this one is going to be a sliding window just by looking at the nature of the problem. So let's, do I have more coffee? No. All right, this is going to be the last problem. I'm going to take a little bit of a break, and then get more coffee. So, but we're gonna do this problem first. So, what do we want to do? I want a sliding window. So, left equals 0, right equals well, first 0, and then we're gonna build out our window. So build window. Okay, so now I want some data structure, and I need to think about this. I need some data structure to keep track of the status in my window. Okay. How would I do that? Would I use a set? No, because I need it to be keep track of frequency as well. So that makes me think of a dictionary again. So I need like my dictionary is equal to default dictionary, and what are we going to have? We're going to have integers because that's the key. So we're going to have, or sorry, this is the value. So key is going to be what? It is going to be letter. Okay, and value is going to be frequency again. Okay, it's actually quite similar to the last one. So now what I want to do is I want to move my window over. Oh, okay. I want to move my window over, and I want to just while right is less than length of S1. Okay. So I need to think about that a little bit. Is it less than or equal to, or is it just less than? So what I want to do is I want to have my right be like this. This is the window that I want. Okay? So there's 3 elements here and there's 3 elements there. So I want right, it's going to start at 0, 0, 1, 2. So this is the second index, so I don't want equal to there. Okay, so now I want to go through each of these and add it to my dictionary. So first off, if right is less than length of 1 is equal to length of S1, length 2 is equal to length of S2, length 2. So if it's less than the length of the second one, so that means that we've kind of hit the case where it's actually not possible to have a substring if our first string is longer than the string that we're trying to find a substring within. That doesn't make any sense. And I can kind of actually, I don't need to do this check. What I can do is I can just come up here and say if length of S2 is less than length of S1, then return false. Okay? Now we're guaranteed that we're not going to run into the limit here. So we can freely expand our window up to this many elements, 3 elements, and we're not going to hit a window. We're not going to hit this window. Okay, so now I want to add this to my dictionary. So I want to do my dictionary indexed at R. So this is going S of R. So this is going to give me the letter. It's going to give me, wait, do I want S? I will also need to loop through my S1 and get that as well. So we can do it. Substring is equal to a default dictionary as well. And this is going to be the same format, and so I will also do this substring of S1 indexed at right. So I'm going to look at the 0th here, okay, and add that frequency plus equals 1, and then I'm going to look at the 0th here and add that letter's frequency. So this one is going to be S2, and then plus equals 1. Okay, good. Now, I want to keep doing that until this loop finishes. Okay. So I built my window. Now what I want to do is I want to keep sliding my window, and I want the window to have a fixed length. I don't want it to kind of grow and then go like this. No, I want it to have a fixed length. Like that. Okay? So, and then I want to stop at the end when the index is about to, when right is about to go outside the bounds of the array. So while right is less than length of S2 now, okay, and now is it equal to? So once right is here, we are going to be at the index here, but length gives the number of elements, so it's going to run this one, and then I'm going to go outside the bounds of the array, and at that point it's going to be equal to, and I don't want to run that. Okay, so what I want to do is check if my dictionary is equal to substring. I don't know if this equals operation actually works. If it is, we return true. And I think that there's also a thing of like, I think when I'm deleting elements from my dictionary, I need to be careful in the way that I do that. So now, if it's not the case, I need to move my right over by 1. Maybe actually I can check this up here. So there's no harm in checking it there, and then just, so that kind of frees me to move my right over by 1 there. Okay, so equals substring is equal to true. What? So I can do right plus equals 1, left plus equals 1. That's sliding the window over by 1 fixedly. But now I need to take away the old values and add the new values in. So let's see, I need so let's take away the old value, which is going to be left. So I'm going to go my dictionary indexed at S2 of left. So I want, let's say that I'm kicking this E out, is going to be minus equals 1. So I just decreased that. And then I can do the left plus equals 1. So then I move that over. Now I need to process this right one. So that is going to be I do increase this, and then I say if right is length of S2, so we're not outside the bounds of the array, then I can, no, I don't think I need this. Then I can add it to my dictionary, so my dictionary indexed at S2 of right, so I'm not going to go outside the bounds, plus equals 1, and now I need to check this. And say if this is equal to 0, I kind of want to null it out, right? Delete or something like that. I don't know. We'll get errors here. But I think this would be the false. I think this would be the algorithm. I'm not sure. See about that delete. I'm not sure. I'm infinite while loop. This is always going to run. Oh yeah. Right plus equals 1. Okay, yeah, it didn't like my delete. Maybe remove? I don't know. If this doesn't work, we're going to GPT to figure out what this one is. It doesn't like it. Okay, fine. It doesn't seem to like my dot remove. Okay. And then it will bounce around because it can't be stable. Okay. So, it's an integer, the value doesn't make sense. Delete, there we go. So del, okay, fine. So delete, and then my dictionary of this S2 indexed at L. Wrong answer. Okay, fine. What's wrong about it? What is wrong with it? But my text is supposed to... Okay, lost my place again. Awesome. Is supposed to represent the target frequency of map S of 1, and by sliding the window should be built from S2. You're comparing... Fundamentally, I thought that that's what I was doing here. Well, I still think that's what I'm doing. So this one, they're changing the window ahead of time. And then they broke that one out, and then move this here. Window is equal to target. Then we return true, so at the end. And then there's an implicit increase in right here. All right, well, I'm gonna come back to this problem. I'm gonna take a little bit of a break. I'm gonna come back to this problem and try to solve it again. So, thank you for watching this video. If you enjoyed it, if you want to continue along with this journey, subscribe. I would love to have you along. Thank you for watching. My name is Timothy Lee Grant, and I will see you guys very soon. I'm gonna make another video today. All right, so see you guys.